First of all, let me ask you a question. Do you guys have any knowledge how to plot graphs? From the mathematics? If you have linear equations, quadratic equations, do you know how do you plot it? So I'll have a basic information and then we'll come to the physics part, okay? Yeah, I think we did this, right? Okay, let's start. Okay, see, we have already completed kinematics. We did motion and gravity, that is the free fall. And now what I want to convey to you is about the graphical information. How we can express this kinematics in terms of graphs, okay? Now, one of the most important things while you are plotting the graphs is to know what equations can we relate to before plotting the graph. Fine? Now, I'll take up some equations and I'll ask you to plot, and then we'll come to motion and we'll try to plot all whatever we have studied, we'll try to plot that graphically, okay? Because understand, very important thing. If you know the equation, sometimes it's very difficult to express it in graphs, fine? But if you can understand the language of the graphs, then believe me, you can write the equations yourself, even if you don't remember. The knowledge conveyed, the information conveyed from the graphs is much more relevant as compared to one that is conveyed from the equations. Because graphical information is the most accurate and it is the most precise form of information. So graphical knowledge is very important, and I would like you to, you should be able to express whatever equations you have. You should be able to express it graphically, because graphically it will help you a lot to convert velocities into accelerations, to convert accelerations into velocities. From positions, calculate velocities. From velocities, calculate the total distance. Everything will be done from the graphs. Okay? Okay. So, if I ask you, let me plot an equation, write down an equation, a basic equation, for example. The equation is this, y is equal to 4x plus 3. Can anyone tell me how do you plot it on the coordinate system? Yes? You put the value of x and then you get what? The value of y, and then you find the point and then you plot it, right? Is that what you do? Yeah. So see, there is an equation of a line in slope-intercept form. In which form? Slope-intercept form. Slope-intercept form. Okay? Now, what is this equation of a line? First of all, you need to understand, very important thing. How many variables are involved? Two variables, one is x, one is. Do you see both the variables have degree 1? So this is a linear equation, isn't it? First you have to understand that a linear equation is always a straight line. Always. Whenever you have two variables and the degree is 1, first consider that it will be a straight line. Now the thing is, how will we able to, to come to the conclusion? What kind of straight line do we have to draw? Do we have to draw a line like this? Do we have to draw like this or this? Is that fine? So for that, what we need to understand is the slope-intercept form of the line. Now the slope-intercept form of the line is y, one of the variables, is equal to some constant times x plus some other constant. Okay? Now as you know, this constant is called what? The intercept. Okay? And this constant, which is associated, which is the coefficient of one of the variables, this is called as, yes? Yeah, very good. This is called as slope. Can you tell what is slope? Slope, that is the mathematical way of calculating the slope. Slope is the steepness of a line. What? Slope is what? the steepness. Do you understand steepness? Steepness means either too steep, less steep, no steep. Negative steepness. Is that fine? Now steepness can be positive. It can be what? Negative as well. So when you talk about slope, it can be positive. It can be negative as well. Is that fine? So when the slope is positive, it means an inclined, a line which is inclined at some positive angle with the x-axis. Is that fine? And when the slope is negative, it means negative steepness. The line is, we have a down slope. We have an up slope, we have a down slope. Is that fine? Is that clear? So every time you have an equation, please try to relate that equation with this. If and only if the degree of the variables is 1. Is that fine? Now, if you look at this equation, x is here as well. But what is the coefficient of x? Yes, it is the slope, right? So here you see that the coefficient or the slope of this line will be 4. Is it positive or negative? Positive means will it be up or down? It will be up. Confirmed it's up. But the thing is, from where do we have to start? So that will be the intercept. Intercept means, what is the value of intercept? C. When x is 0, y is equal to what? C. Isn't it? So when x is 0, y is equal to c. Isn't it? So this is called as the intercept. It is the value of y when x is 0. Is that fine? Or it is the value of on the y-axis where the line intersects the y-axis. Is that clear? So here when you look at this equation, you have an intercept equal to 3. Isn't it? So intercept is equal to 3. And then you have a straight line, and that line is inclined at some angle such that its steepness, its slope is 4. Is it positive or negative? Positive. So you have to draw a line. Is that fine? Is that fine? Now can you tell me what kind of line is this? Anyone? How you plot this line? Yes. Yes, Khalifa. Starting from origin. And what will be its slope? Is there any intercept? No? So first of all, as I told you, you have to compare it with what? With which equation? Yes, y is equal to mx plus c. Now, if you look at this equation, very important. Y has a coefficient of 1. Here it has. So it should be, this 4 should be eliminated. How do you eliminate it? Divide both sides by 4. Very good. So that will give me y is equal to 3 upon 4 times x. Is that fine? Now we have something related to that. What is the intercept? 0, yeah. So here we are seeing that the intercept is 0. Okay? When the intercept is 0, what is the slope? Slope is something related to x. So the slope is, yes, 3 upon 4. Now can you plot the line? Yes, you can. So at least not accurately, but you can imagine how the line will look like, isn't it? So yeah, so the intercept is 0. It will start from the origin, okay, and then the slope is positive, so it is, and it is less, isn't it? So that will be something like this. Is that fine? Clear? Yes. Okay. Okay. Now tell me. How about this? 4y plus 3x is equal to negative 2. Tell me, how do you do this? How do you plot it? Yes? Oh, very good. Yeah. So the next step would be something like this. Yes? And then divided by 4. Yeah. So y would be equal to negative 3 upon 4 times x, negative 2 upon 4. Is that fine? So you can still simplify it as negative 3 upon 4x, negative 1 upon 2. Is that fine? That would be your y. And now you can compare it with the standard equation, isn't it? Can you plot it? Tell me how will it look like? Yes? So we have to, first of all, we have to start from negative 1 by 2. So negative 1 by 2 will be below the x-axis, isn't it? So we have to start from here, and this would be negative 1 upon 2, okay? And then what about the slope? Is it positive or negative? Slope is negative. Is the line up or is it declining? It is declining, so the line will be something like this. Is that fine? Clear? I hope you will be able to apply this concept in kinematic equations. Okay? Is that fine? Now, if I give you the basic equation, which is the first equation of motion, V is equal to U plus AT. If you remember, I have told you what is the value of A? Is it a constant or a variable? Yes, A is a constant. I told you kinematic equations can only be used when acceleration is very good. Initial velocity, does it change or is it constant? Constant. A body has some initial velocity. So even if it is moving for 100 seconds, it is moving for 100 kilometers, initial velocity was there always, right? That's also constant. So do you think that we have this and this as constants? Yes or no? Okay, what changes? Do you understand that time continuously changes? Do you understand its final velocity changes with time? So are there two variables? How many? What is the degree of these variables? So is it linear equation? What will be the graph? Straight line. Confirm? Now the thing is, how will this straight line look? So let's plot this graph, for example. This is the final velocity versus the time. Okay? Can you tell me? You confirm that it is what? A straight line. Did you? Now if it is a straight line, you have to compare it with y is equal to mx plus, isn't it? So on the y-axis, what do you have? V. So this is y. Isn't it? On the x-axis, you have what? So is this x? Yes or no? Now tell me. Whatever is related to x is called as, what is the slope here? Acceleration. Is that fine? So this is the slope. And what is the intercept? U. Yeah, so this is the intercept. Is that clear? Do you understand how you relate? Now tell me, if you want to plot the graph, is the intercept positive or negative? It can be negative as well. A body has initial velocity of minus 10 meters per second. Isn't it possible? So it depends, whatever is given in the question. But here, for example, we are taking it as positive. So that means this will be the initial velocity, shouldn't it? So the initial velocity is how much? The initial velocity is how much? U, isn't it? And then what is the slope? Sometimes A is also negative. You call that as retardation, isn't it? For example, this time it's acceleration. So acceleration is what? Positive. So how will the graph look like? Will it be something like this? Yes. Now understand, very important thing. From the slope of velocity time graph, the slope of which graph? Velocity time graph. What do you get? What is the slope of velocity time graph? Yes. Acceleration. This is important. So the slope, every time you plot a velocity time graph, whenever you calculate the slope of such a graph, understand that slope will always give you acceleration. Is that fine? Is that fine? Now I have a question for you. There are two bodies and their velocity time graph is given. Their velocity time graph is given. There are two bodies, one and the other one is this. The question is, which body has more acceleration? Yes. Why? Because steepness, the slope of graph 1 is that fine? Is this clear? Everything is conveyed from the graphs. You don't need to calculate. Is it clear? First copy this, we'll come to the other parts. And write it down. The slope of velocity time graph gives acceleration. Should I change it? Yes? What about this? The velocity time graph of a body, if for example, it is like this. The velocity is constant. What is the acceleration? Zero. See, two things. Two things help you to calculate it. One is the slope, it is the steepness of velocity time graph. Is there any steepness? There is no steepness, acceleration is zero. Point number one. Point number two. You said, sir, velocity is constant. Did you? When the velocity is constant, by the definition of acceleration, it is the rate at which velocity changes. Is there any change? No. Is that clear? That is how you understand. Okay, tell me one more thing. So acceleration here would be zero, isn't it? Now, if I ask you, there is a graph like this. Now, this is something I was not supposed to tell you, but because you understand the concept of acceleration, what about this? Is it constant? What is acceleration? Yes. It is the rate at which velocity changes. Point number one. Point number two. Acceleration is the slope of velocity time graph, isn't it? Now, if you look at the slope, the steepness, initially the steepness is something like this, is it? But at this point, it is like this, is it? At this point, it is more inclined, isn't it? So, is this steepness constant? It's changing, isn't it? So acceleration is not constant. It is changing, first of all. Now the question is, if it is changing, is it increasing or decreasing? It is increasing. So here, acceleration is changing. And what we see it as, it is increasing, isn't it? Do you know what is the change in acceleration called? Change in acceleration, what is it called? Yes, anyone? See, change in distance is called as speed. Change in displacement is called as velocity. Change in velocity is called as acceleration, isn't it? But what is the change in acceleration called? You would have never studied this because this is not in your syllabus. This is called as a jerk. Is that fine? Sometimes the driver is very, driving, in a very what do you call that? Yeah, reckless driving. Sometimes he stops, or sometimes continuously pushing up the accelerator, isn't it? You don't just tell him you're a jerk because he's continuously changing the acceleration. Yeah, it is true. Change in acceleration is called as jerk. Okay? Okay, so let's come to the graphs. Today there will be a reward if you plot the graphs very well. So, a llama gallops gracefully at a constant speed in the positive direction of 3 meters per second for 3 seconds. Okay? So there is an animal which has a constant speed in the positive direction. Okay? And the speed is 3 meters per second. The question is, and for it is for 3 seconds. Fine. The first graph that he's asking us, let us start from this point, is what will be the velocity time graph or the speed time, because it is in the positive direction. So direction is fixed, is it? And the magnitude is also fixed, isn't it? So when both are fixed, tell me what will be the velocity time graph? Is it constant? Velocity is constant. Constant means it will be a, isn't it? Now tell me, very important thing. Do you know what by the definition of velocity, what is velocity? The rate of change of, isn't it? Rate of change of speed, rate of change of position, rate of change of displacement, that will give you speed or velocity, isn't it? Now, when I talk about speed, let me go to some equation first. Let me write it here. Speed. You say that speed is distance over time, isn't it? Or you say velocity is what? Yes, displacement over time, isn't it? Likewise, you said acceleration is velocity over time, isn't it? But you know how you calculated acceleration from the graph? You calculated acceleration from the slope of velocity time. Did you? By that concept, can I say speed, it is the slope of distance time graph? By that concept, can I say velocity is the slope of displacement time graph? Write it down. Write it down. Speed and velocity are the slopes of distance or displacement time graph. Speed and velocity are what? The slopes of distance or displacement time graph in 1D. In 1D, okay? Because in 2D, the two are different. Speed will only be calculated from this, and velocity will only be calculated from this, okay? In 1D, one dimension, motion in 1D. Because in 1D, distance and displacement is same, right? That's why. Is it clear? Any doubt? Now, let us come to this graph again. So, we plotted the first graph, that is the velocity time graph of this body. By that graph, can you tell me what is the acceleration? Yes, it is 0. How will the acceleration graph be? It will be 0. Isn't it? The acceleration time graph will be like this. No acceleration. Acceleration is 0. Is that clear? But the question is, what will be its position time graph? See, you need to understand. From position time graph, what do you get? From the slope of position time graph. Yes? You get speed, you get velocity, but that velocity, that speed is constant. So that means slope of displacement time graph should be possible manner in which you have to plot this so that its slope is constant. If it is a straight line, isn't it? Simple. See, if it is a straight line, what is the slope? Constant everywhere, isn't it? So that is why when, see, understand, when the slope of this line is constant everywhere, that is why when you plot its velocity time graph, it is constant. And because velocity is constant, therefore acceleration is zero. Do you get it? See, three graphs depicting the same information, that acceleration is zero, that means velocity will be constant. When velocity is constant, that means the position will be changing continuously with time, isn't it? Well, see, this graph I can also plot like this. Do you know speed is equal to distance over time? Yes? So can I say which implies, can I say distance is equal to speed into time? Can I? Now in this graph, is this distance? Is this time? So is this y? Is this x? Both are linear, so it has to be a straight line. What is speed? It's constant, isn't it? So it will be what? The slope. Now compare it with the standard equation that we just studied. Linear equation confirms straight line. Is there any intercept? No. It has to start from origin. So you have to start it from the origin and then it is straight line. Because speed is positive 3. Is that clear? So the graph, distance time graph, its slope will be equal to how much? Yes? 3. Because the slope of distance time graph is speed, and speed gets given. How much? How much will this be? This will also be 3. Isn't it? Constant. Is that clear? Any doubt in this? If this is clear, can you plot this at your places? Yes. Anyone? It's simple. You need to just understand what is happening. The only thing here, very good. See, understand. The constant acceleration. What is the acceleration? Constant. It is one. Constant means it will not change. So let us go to the acceleration time graph. The acceleration time graph will tell me like this, isn't it? Because see what is happening. An alpaca is initially aggressive, and all of a sudden, for example, there is a fierce animal, capybara. It tries to chase it. Okay, so while chasing, so he will run away. So initially, initial velocity will be what? Zero. But finally, will be changing, right? Because he is accelerating at a constant rate, 1 meter per second square, isn't it? Now tell me, acceleration is constant. But what is acceleration? Yes, how do you get it? You get it in two ways. Either calculate the change in velocity per unit time or from the slope of velocity time. So when you go to the velocity time graph, its slope is constant, right? How will the graph be? Exactly, something like this, isn't it? See, you are not needing the equation. Otherwise, I can just help you with the equations. See, what is V is equal to U plus, isn't it? What is the initial velocity? 0. So V is plotted on the y-axis, time is plotted on the acceleration is positive or negative? Positive. So the graph will be something from the origin and up, isn't it? So the slope of this graph will also be 1 meter per second square. Is that clear? Is it clear? Now what about its displacement? Yes. Anyone? Why? Exactly. So now you understood what is happening. There are two ways in which you can understand. First, the velocity is not constant. It is changing. So that, how do you get velocity? From the slope of? Yes? How do you get velocity? From the slope of distance time graph, isn't it? Is the velocity constant? No. Velocity is changing. When velocity is changing, that means the slope of distance time graph will also be changing, isn't it? But it is only positive, so that means it will be increasing, isn't it? So the only possible graph that we have is something like, where did I keep it? Something like this, isn't it? But how do you confirm it? Let me come to the equation. Do you know we have an equation that distance is equal to ut plus half of acceleration times t square? Do you know initial velocity in this case is 0? So do we have distance is equal to half of acceleration times square? Have we plotted this on the y-axis? Yes. Have we plotted this on the x-axis? Is it? But what is the degree? Is it 1 or is it 2? It's 2. So it's not linear. The line is not straight. Confirmed. When the degree is 2, what is the graph? Parabola. Isn't it? So remember, when the degree is 2, it is a quadratic equation, isn't it? If the quadratic equation is there, the graph will always be a parabola. Is that fine? So how do you draw a parabola? Remember. Parabola is a family of curves. It's of 4 types. How many types? Either it can be asking God for forgiveness, or it can be in ruku, okay, or it can be dancing, right or left. Is it clear? These are the 4 kinds of parabolas. Either asking God for help, or in ruku, or right and left. This is the dance that he does, and then he asks God for forgiveness. Is that fine? Now see, how would you know which kind of a graph do we have? These are 4. How many? So I will help you to plot all the 4 so that you never confuse between parabolas. Is that fine? Now see. The first kind of parabola, say for example, this is the y-axis and this is the x-axis. The first kind of parabola is if y is equal to some constant times x squared. Okay? So how do you know among the 4 what kind of parabola is this? Can anyone tell me? How will this parabola look like? Will it be asking God for forgiveness? Will it be in ruku? Will it be right or left? Yes. Anyone? It's going to be up. How? Because it's positive. Yeah. Right or left? Up or down? It is parabola. Confirm. We know. Because the degree is 2, it is parabola. The question is what kind of parabola? See, remember, how do you figure out? First of all, you need to know that check the variable on which we have the highest degree. Here in this case, which is the variable which has the highest degree? It is x. Which variable is left? Y. K is a constant. Y is left, isn't it? So y is the variable which has degree 1, isn't it? So remember, First thing from this information is your parabola will be symmetric about the y-axis. Is it clear? That means y-axis will bisect it into two halves. So there are only two possibilities. Either it is up or it is down. Because when you plot the y-axis, it will cut it into two parts, isn't it? Is it clear? But the question is it up or down? Why? Because this constant coefficient here is positive. Is it clear? So this parabola, if you want to plot it, this parabola is something like this. And remember, I'm again repeating this thing, parabolas have two arms, they have two limbs. Never plot a parabola with a single limb. It always is like this. Is it clear? Then you have one more parabola. Y is equal to negative kx squared. Yes, how do you figure it out? First, understand. Power is on x, so parabola will be symmetric about y. But the coefficient is negative. So y means either up or down, but negative means down. So this is it clear? Is that clear? Next. If x is equal to ky squared. See, yes. So power is on. The graph will be symmetric. The parabola will be symmetric above x-axis. Is that clear? But there are two possibilities. Either dancing towards right or left. Isn't it? But what is the coefficient? Is it clear? And what the last one? X will be equal to negative ky squared. Yes, now tell me. It will be on the left. That is it. Clear? So this is, I hope you will be able to figure out. I'll write them down. 1, 2, 3, 4. 1, 2, 3. Is that fine? Yeah. Now in mathematics you call them upward, downward, right and left sided parabolas. Is that clear? Now let us apply this concept to our equations. Is the concept first of all clear? Is it? Okay. Now let us come to the question. Did you copy this? Okay, let me come to the equation. What is our equation? See? X versus t. Isn't it? So just now I told you we have an equation. Where did I write that equation? We have an equation. So this is the equation, right? Is it? For this case, initial velocity is 0. So we have this equation, isn't it? Now if I happen to plot a graph, between S and t, because all of you know that acceleration is constant, isn't it? So don't you think S versus t graph also has to be a parabola? Yes or no? So if it is a yes, now what kind of parabola? Let us see. Power is on t, isn't it? So which variable is left? S, which is the y. So graph will be symmetric about up or down. Yes? Up. Why? Because as per the question, acceleration is 1 meter, which is positive, and 1 meter is also a constant. So this portion is a constant. Is it clear? So the parabola will be asking God for forgiveness. Why? Because someone is changing the alpaca, isn't it? So the graph will be like this. See? Isn't it? But tell me, is it the correct graph? Is this the correct graph? I told you parabolas have how many limbs? Two limbs. Two limbs. So we did plot a graph as per our concept, but is it the correct graph? Why? Anyone who can tell me if this is correct or not? Why? See, understand. We cannot be plotting both the limbs. We cannot be plotting. See what? Because when you look on the left time is negative. Is it possible? Therefore, our graph, actual graph, has to be only this. Is this clear? This portion will not be drawn, but it doesn't mean you limbs up. There is only one limb. There are always two limbs, but in this case it is not possible because on the other side the time is negative. Is it clear? So when you come to the graph, the actual graph, your graph will be something. Is this clear? Is it clear? Which equation did we use? We used x is equal to half of 80. Clear? Any doubt? Will you be able to plot the graphs? Now, I hope you will be able to do this. See two graphs, distance, time, and velocity time. Capybara is initially at x equal to 1. Initially, the distance is x equal to 1. With respect to some origin, okay, with respect to origin, he is already at some position. At 2 seconds, it starts to move in the positive direction at a constant velocity up to x equal to 2. So he is moving towards the positive direction. From x equal to 1 to x equal to 2, but at a constant velocity. The velocity is constant. And then it stops at t equal to 3. Then there it stays at rest. The question is, how will its velocity and displacement and maybe the acceleration time lap will be? So first of all, let me tell me about this, then we can go from here. Yeah. Simple. Don't confuse yourself. Whatever you understand, try to plot. Yes, Tabri. Yes. Yeah. He was already up to which point at x equal to 1. That means you already equal to 0. And time was 0. So you get x equal to 4. At time t equal to 2. And now this is a equal to 4. After then he found then 2. So if he doesn't change, at 2 he starts to move in the positive direction with a constant velocity to x equal to 6. Now, this is x equal to 1, this is x equal to 3. To here, he goes at a constant velocity. Even the slope of this illumination, is it? This will then have slope velocity, but that is constant for velocity. Yeah, straight. Velocity, velocity, you can just simply time. Because this is constant. So this is the one it has to stay up to x equal to 3. And stops at p equal to 3. And stops at, okay, till then, how much time is it? So he reaches 2, but the time is 3. Okay? And then it stays. The stage then means if x time will go on, it then means constant. Velocity, not everything. Here, Here the values. So here from 2 to 3 you have to show that. Here again we have to. Something like this, yeah.
But then it's speeds up.
And yeah, something. Is velocity every time? Or where? He starts at time equal to 2. Before that, he did not see. There is velocity. It is from 2 to 1. Then he will not go the rest. After that, he again at rest. As per this plot, yeah. You read the question again. Anyone else? No? How? Initially, it was equal to 1. But this velocity starts to increase, continuously again velocity after t equal to 2. Till then, he doesn't move. So there is no velocity. And then, what is it? No. He's flying, right? From 2 to 3, he follows the direction, right? And velocity. So that means from 2 to 3, velocity. Then again, but now, what is the velocity? Velocity is the slope of this graph. And then here velocity. And then here simple. You just have to take it in time. Oh, you have explored this technical study, no? You didn't know this? Yes, simple. The other graph? Why did you start from 0? I don't understand. She took 1 from x equal to 1. Huh? Stand. X was 3 time 1. X is 1. And then what? It is possible, but it is a constant rate. It is not a variable. If it was variable, yeah, of course. Yes, you? Yeah. Sure. Oh my God. How come we plot parabola? Since he understands, there is no chance that there can be a parabola. See, this thing is not possible. This is only possible when there is a jerk. Okay, when acceleration is changing. This is non-uniform motion. What we are discussing is uniform motion, isn't it? So it will be there sometimes, but that will be a particular case. At that time he will say velocity is changing. Velocity is, but is the velocity changing? If you again read the question, now if I try to, plot it here, see, you will feel this question was easy. See, how to read between the lines. I know you do not understand the question. That is the reason you are not able to plot the graphs. See what is happening. x equal to 1. Someone is initially at x equal to 1. Initial means what? I told you last. It is from where the time starts. So if we are plotting this graph, initially someone is already at x equal to 1. Someone is already here when time was 0. Is that fine? At time 2 seconds. Now the time has already reached 2 seconds. So till 2 seconds, do you have any information? No, you don't have. That means up to 2 seconds, up to this point, he is still ahead. Okay? Is that fine? There is no change. X equal to 1. 1 second, 2 seconds, he is still there. Now all of a sudden he starts. So now there is velocity, isn't it? But that in which direction? Positive direction. So velocity will be positive, isn't it? At a constant velocity. So the velocity is constant as well. Constant velocity means, yes, what does it mean? There are two things that you can convey from constant velocity. First, there is no acceleration. Is it? Second, very important thing. If you plot its velocity time graph, so when you think about this portion, the positive direction and constant velocity at x equal to 2, okay? So here it means when velocity and time graph are plotted, okay, at time 2 seconds, his velocity is constant, and up to which point? Time t equal to 3 seconds, isn't it? So from 2 seconds, he starts to have a constant velocity, and that velocity is continued up to what time? 3 seconds, and at 3 seconds he stops. So velocity is constant from which time? From up to 3. From 2 to 3, from 2 seconds to 3 seconds, his velocity is constant. So if you go from the velocity time graph, from 2 seconds to 3 seconds, his velocity is constant, for example. Isn't it? Is that fine? But tell me, velocity time graph, the velocity is obtained from the slope of distance time graph, is it? Is it? Is it or no? Yes? Now tell me, if the velocity of the body is constant, what will that be the slope of distance time graph? It will be also constant, isn't it? But constant slope means straight line. And is it positive or negative? It's positive. So that means that from 2 seconds to 3 seconds, velocity time will be like this, but its displacement time will be like this. Is that fine? But again, you have to understand. From 2 to 3 seconds, how much distance has he covered? He's at x equal to 2, isn't it? He had started from x equal to 1. So from 1 x equal to 1 to x equal to 2. So he is somewhere here, isn't it? But how has he reached there? With a constant velocity, is it? So the graph will be something out of this. Is it clear? Is it clear? So velocity is constant. And then what happens? Then stays there at, when someone is at rest, will his x change? No. But time will go on, x will not change. X will not change. X will stay at 2. Is that clear? Is it clear? Now, if you have to plot its velocity time graph, if you have to plot its velocity time graph, one portion we have already drawn. From 2 to 3, velocity is constant. But tell me, was he in motion before 2? Is he in motion after 3? No, he's at rest. Khalas. Zero velocity. Is it clear? Yes? There is no velocity. So graph you can plot like this. From 0 to 2 seconds, there is no velocity. From 3 to infinite time, there is no velocity. But from 2 to, see everything. much easier to read from the graph. From 2 to 3, constant velocity. Isn't it? Now, if I ask you, what will be its acceleration versus time graph? Acceleration versus time graph. Yes. Yes. What is acceleration? It is the change in velocity, or it is the slope of velocity, isn't it? Check velocity time graph. What is the slope? What is the slope? What is the slope? Zero. Every time it's zero. So its acceleration time graph will be, yes, how will it look like? It doesn't have any acceleration. Is it clear? That's it. That's how you have to understand. If now tell me, was this reading more difficult as compared to the knowledge that you get from the graph? See, from the graph it is clear. Up to 2 seconds, he is at rest. There is no change. From 2 to 3, he is moving, isn't it? And from 3 again, he is at rest. Is that fine? From velocity time graph, rest, no change, velocity is 0. Then velocity is constant, velocity is again 0. And acceleration, there is no acceleration at all. Is that clear? It is very important for you to understand how you plot it. Very important. Because, as I told you in the beginning, graphical knowledge is more important than the equations. Equations will lie to you. They will lie to you. You will get incorrect information from the equations sometimes. But if you know how the graph looks like, you will always be correct. I promise you that. Initially it is difficult, but later on it will get easy. Is that fine? Any doubt? So I would ask you to, in the next class, we'll be coming up with what we already touched today actually. What is slope, how you plot everything. This is a graph, okay? I would like to evaluate, I think the time is over, yes? Okay, in the next possible class, maybe tomorrow, inshallah, we'll be trying to understand what is this graph conveying to us, okay? And can we write down the equations for this graph? From the equations, graphs become difficult. From the graphs, equations are easy. Is that fine? So inshallah, we'll try that. Any doubts? Anything you would like to ask? Okay then, thank you so much. God bless you all. We'll be evaluating your results